So for completeness, just let's have a look at processes that remove or erode or destroy density stratification. Okay? And this can happen by either by mechanical steering. You can have, if you have a big storm, it can create enough energy to steer the surface mix layer through mechanical mixing mechanisms, or by a mechanism called convection, which follows from unstable density stratification. Okay, and again, which mechanism, which process creates unstable density stratification? And the key one is the interaction with the atmosphere, which actually increases the density near the surface. Okay? So, for example, cooling of the surface ocean creates unstable density stratification. Or strong evaporation or ice formation actually creates the surface salinity. These are the processes that can create a convective mixing. And let's see how it looks like. Let's have this a typical, just a little bit more information on this mixing. Okay, you have something which is called thermohaline convection. And let me just see. I just need to, just a second. Where are we? Because there's a typo in here. Thermohaline convection. Here we are. It's corrected, which means thermo relates to cooling effect, and haline means refers to a salinity effect. Okay. So what happens? What it creates is actually it creates something which is called convection cells, and the convection cells operate to mix the surface layers as shown in this little sketch. You look from the side. Buoyancy flux refers to the density increase near the surface, and the typical feature of these convection cells is that they usually have the same ratio of 1 between horizontal and vertical scale. So the depth they reach is the same as the horizontal, the distance between the convective elements. What controls or modulates this convection mechanism is the ambient density stratification, and this can be expressed by something that we call a stability frequency. It's just for additional detail. There is a parameter which tells you how much does the density change with depth. Okay, this one is the vertical gradient of density. This is what these symbols mean. How does density change with depth? Multiplied with gravity, divided by an average density, and with a minus. This is what we call the stability frequency square. If it's positive, it's a stable stratification. If it's 0, means neutral. The density is the same everywhere. And if it's negative, this is unstable stratification. Okay, let's just look at a simulation of a convection process where this is a fluid cooled from above. It's a numerical simulation, and you can see the plumes and the mixing that happens on a time scale of 360 minutes simulated here. And just go back and show it again. You can see that the scale is very small, and you get mixing. There's heavier water falling down, but you also get the upwelling of other water pieces, and it's all steered through this mechanism. Again, this is what we call a thermohaline convection. And by the way, this is the mechanism, and I'll just show you that on the next slide. This is the mechanism which leads to a mixed layer deepening over the winter month. Okay, in many, many regions, except for the ice-covered regions on Earth. Okay, because the cooling creates the mixed layer deepening due to convection. At the end of the winter, you have a deep surface mixed layer, and then over summertime, you get again a warm, shallow surface mixed layer. Okay? This is what we call the seasonal thermocline. All right.